Recording another supplemental video for the Spec 1 assignment. Someone told me that everything worked really well except for the gold nanoparticle data has been pretty tricky. So that's what I have up here on my screen that you can see. And I'm just going to kind of walk you through how to do something that doesn't want to fit right away. And to show you that, so first of all, what I did was I plotted this over a range where the spectra fits really nice. I did from 450 to 600 nanometers and 0.08 to 0.18 absorbance units. That centers the spectrum really nice on the graph. And if I go to do this initial curve fitting, here I'm just going to use, so this is the equation I came up with. So here is the Gaussian portion, and here's my baseline portion. And my baseline, I used a polynomial. So you can see there's x cubed plus x squared plus x plus some baseline. And I found that when I just did this equation directly, it didn't want to fit so well. And I'll show you that now. So I have to enter guesses of coefficients. So A, I think about 0.05 works. B, you can see it's like right around 530 nanometers. Maybe the width of this thing is, I don't know, 50 nanometers or so. And so for my Y00, 0, I'm going to say like 0.12 right there. Okay, and then now here's all these other polymeric terms. I'm just going to put in like really small values for now. I'm just kind of guessing, and I'm going to do this graph. And when I push the graph button, like nothing shows up here, as you can see. So what I can do is just zero all of those out, and then I get a result right here, okay? And so maybe it needs to be narrowed down a little bit. Yep, so I made it a little bit narrow. And so now this is going to kind of help me find some good guesses. I'm just going to leave these all as 0, and I left this as 0.12 because it's starting at 0.12. And now I push do it, and that actually does pretty okay. The first couple times I was playing with this, it didn't really want to find a great fit right away. So another thing I recommend doing, go to graph and show info. And I'm going to use these cursors. I'm going to drag the A cursor and put it like right there. And I'm going to drag the B cursor and put it right there. And now I'm going to go back to this curve fitting. And up here, I'm going to say on data options, cursors. And let's say do it. And hey, look at that. That helped quite a bit. Okay, so that's actually a really nice fit. So if it doesn't work like this right away, so another thing that you can do, so for example, I'm going to move these cursors a little bit closer into the main peak, like right there, okay, and go back to analysis curve fitting. And then on my output coefficients, I'm just going to say, again, 0 on all these things. I'll say graph now. And you can see it's only graphing this small part of the region right here, okay? And I'm actually going to force all of these to stay 0 to prove a point here. There we go. So now I just have, so all of my, polynomial terms I forced to be 0, and my baseline term is coming out to be about 0.11 or so. And so you can see that's fitting the Gaussian really nicely. And so if you get it to fit this Gaussian nicely here, then what you can start to do is say, okay, now I'm going to still leave the narrow cursors. I'm going to still leave that, and I'm going to uncheck those, and we'll say do it. And that's actually an even better fit. It allowed those polynomial terms to come in and have some kind of a value. And that's pretty cool. But then now I'm going to kind of expand this out just a little bit more to include this, shifting baseline. And again, you go to data options and push cursors if you update it. And now let's say do it. And all right, that's actually pretty decent. And it's telling me the peak is 527 And that makes sense. You know, I can put this thing at 527, and there you can see 527 nanometers at an absorbance of about 0.15. So that really makes good sense. And to confirm you're getting that 0.15 correct, then technically, right, it'll be, it should be approximately the, well, it worked up here, but when we zeroed out all the values, I'll show you, right? Like this 0.11632 plus 0.04 is about 0.15. That was when I had all these other values zeroed out. So that's just a way to confirm. But the fact that this is, you know, fitting the data nice, I'll make it so we can see this better. Then that works pretty well. So again, if you're struggling with getting these things to fit, just try, you know, only fitting the peak, like narrow down the peak. Using these cursors, I think really helps. And, you know, telling the under curve fitting on the data options menu, pushing that cursors button, I think that makes a big difference. And again, I had the best success on the baseline of this gold nanoparticle by doing a polynomial. So that's y0 plus y1 times x plus y2 times x squared plus y3 times x cubed. And then again, fiddle around with these coefficients and push this graph now button, right? And that's how you can really see, oops, now you can see, look, it got totally messed up. So, oops, perfect example. So now let's say that this happened to me and that it didn't like this. So I'm going to go back and narrow my cursors one more time. And cursors, I think maybe because I was fiddling around with that cursor last time on the peak. Yeah, so that helped. So now I'm going to expand these cursors out a little bit. Analysis curve fitting, cursors. Okay, beautiful. So that works pretty good. And then, you know, what I want you to do is then plot, you know, the separate equations for the baseline and for the peak, just like you did for the other examples. Okay, I hope that helps, folks, if you had trouble with this gold nanoparticle data. Happy fitting!